Hello everyone. In the previous lecture, we have learned about token-based authentication and why PASETO is better than JWT in terms of security practice. Today we will learn how to implement both of them in Golang to see why PASETO is also much easier and simpler to implement compared to JWT. Alright, let's start. First, I'm going to create a new package called token. Then create a new file maker.go inside this package. The idea is to declare a general token maker interface to manage the creation and verification of the tokens. Then later we will write a JWT maker and a PASETO maker struct that implements this interface. By doing so, we can easily switch between different types of token makers whenever we want. So this interface will have two methods. The createToken method takes a username string and a valid duration as input. It returns a signed token string or an error. Basically, this method will create and sign a new token for a specific username and valid duration. The second method is verifyToken, which takes a token string as input and returns a payload object or an error. We will declare this payload struct in a moment. The role of this verifyToken method is to check if the input token is valid or not. If it is valid, the method will return the payload data stored inside the body of the token. Okay, now let's create a new payload.go file and define the payload struct inside it. This struct will contain the payload data of the token. The most important field is username, which is used to identify the token owner. Then an issued@ field to know when the token is created. When using token-based authentication, it's crucial to make sure that each access token only has a short valid duration, so we need an expired@ field to store the time at which the token will be expired. Normally these three fields should be enough. However, we want to have a mechanism to invalidate some specific tokens in case they are leaked, so we need to add an ID field to uniquely identify each token. Here I use a UUID type for this field. The type is defined in the Google UUID package, so we have to run go-get command to download and add it to the project. As you can see here, the package has been added to the go.mode file. Let's continue. I'm going to define the function newPayload that takes a username and a duration as input argument and returns a payload object or an error. This function will create a new token payload with a specific username and duration. So first we have to call uuid.newRandom to generate a unique token ID. If an error occurs, we simply return a new payload and the error itself. Else we create the payload, where ID is a generated random token UUID. Username is the input username. Issued@ is time.now and expired@ is time.now.addDuration. Then we just return this payload object and a new error. And we're done. Now we're going to implement a JWT maker. We will need a JWT package for Golang. So let's open the browser and search for JWT Golang. There might be many different packages, but I think this one is the most popular. So let's copy its URL and run go-get in the terminal to install the package. Okay, the package is installed. Now let's go back to Visual Studio Code. I'm going to create a new file, jwtmaker.go inside the token package. Then declare a new type, JWT maker struct. This struct is a JSON Web Token Maker, which implements a token maker interface. In this tutorial, I will use symmetric key algorithm to sign the tokens, so this struct will have a field to store the secret key. Next, let's add a function new JWT maker that takes a secret key string as input and returns a maker interface or an error as output. By returning the interface, we will make sure that our JWT maker must implement the token maker interface. We'll see how the Go compiler checks this for us in a moment. Now, although the algorithm we're going to use doesn't require how long the secret key should be, it's still a good idea to ensure that the key should not be too short for better security. So I will declare a constant min secret key size equal to 32 characters. Then inside this function, we check if the length of the secret key is less than min secret key size or not. If it is, we just return a null object and an error, saying that the key must have at least 32 characters. Otherwise, we return a new JWT maker object with the input secret key and a null error. Now you can see a red line here because the JWT object that we've created doesn't implement the required methods of the token maker interface, which is a return type of this function. So in order to fix this, we have to add the create token and verify token methods to this struct. Let's copy them from the maker interface and paste them here. Then let's add the JWT maker receiver in front of each method. Alright, now you can see that the red line is gone, since our JWT maker struct has all two required functions of the interface. Okay, let's implement the create token method. First, we create a new token payload by calling new payload and pass in the input username and valid duration. If error is not null, we return an empty token string and the error. Else, we create a new JWT token by calling the jwt.newWithClaim function of the JWT Go package. This function expects two input arguments. First, the signing method or algorithm. I'm going to use HS256 in this case. Then the claims, which is actually our created payload. Finally, to generate a token string, we call JWT token.signedString and pass in the secret key after converting it to byte slice. Here we have an error because our payload struct doesn't implement the JWT.claims interface. It's missing one method called valid. The JWT Go package needs this method to check if the token payload is valid or not. So let's open the payload.go to add this method. The signature of this method is very simple. It doesn't take any input argument and only return an error in case the token is invalid. You can easily find this method in the implementation of the JWT Go package. The simplest but also the most important thing we must check is the expiration time of the token. If time.now is after the payload.expire date, then it means that the token has expired. So we just return a new error saying token has expired. Actually, it's better to declare this error as a public constant so that we can check the error type from outside. I'm going to call it error expired token. And here we just return this error expired token. If the token is not expired, then we simply return null. And that's it. The valid function is done. Now back to our JWT maker.go file, we can see that the red line on the payload object is gone. Now as we've imported the JWT Go package, we should run go mode tidy in the terminal to add it to the go.mode file. The JWT Go version I'm using is 3.2.0. If you're watching this in the future, it might be possible that you will use a newer version, such as 4.0, then the function and interface signature might be different. However, the idea should be similar. Okay, now the create token method is done. Let's move on to the verify token. This will be a bit more complicated. First, we have to parse the token by calling jwt.parseWithClaims and pass in the input token string, an empty payload object, and a key function. What is a key function? Well, basically it's a function that receives the parsed but unverified token. You should verify its header to make sure that the signing algorithm matches with what you normally use to sign the token. Then if it matches, you return the key so that JWT Go can use it to verify the token. This step is very important to prevent the trivial attack mechanism, as I explained in the previous lecture. Alright, I'm going to copy this function signature and paste it here. Let's set this input argument's name to token, and its type should be jwt.token. Then we just pass the key function to this parseWithClaims call. Now in the key function, we can get its signing algorithm via the token.method field. Note that its type is a signing method, which is just an interface. So we have to try converting it to a specific implementation. In our case, I'm going to convert it to signing method hmark because we are using HS256, which is an instance of the signing method hmark struct. This conversion can be successful or not. If it is not okay, then it means that the algorithm of the token doesn't match with our signing algorithm, so it's clearly an invalid token. We have to return a nil key here with an error invalid token. I'm going to declare this new error inside the payload.go file, the same place as the error expired token. There are different types of error that will be returned by our verify token function. Okay, back to the JWT maker. If the conversion is successful, then it means the algorithm matches. We can just return the secret key that we are using to sign the token after converting it to byte slice, and a nil error. Okay, now the key function is ready. Let's continue with this PostgreSQL function call. If it returns a not nil error, then there might be two different scenarios. Either the token is invalid or it is expired. But now things get more complicated when we want to differentiate these two cases. If we follow the implementation of the JWT Go package, we can see that it automatically calls token.claims.valid function under the hood. And in our implementation of this function, we are returning token expired error. However, JWT Go has secretly hidden this original error inside its own validation error object. So in order to figure out the real error type, we have to convert the returned error of the PostgreSQL functions to JWT.validation error. Here I assign the converted error to the v_error variable. If the conversion is okay, we use the errors.is function to check if the v_error.inner is actually the error expired token or not. If it is, we just return a new payload and the error expired token. Otherwise, we just return nil and an error invalid token. In case everything is good and the token is successfully parsed and verified, we will try to get its payload data by converting JWT token.claims into a payload object. If it's not okay, then we just return nil and error invalid token. Else we return the payload object and a nil error. And that's it, the JWT maker is done. Now let's write some unit tests for it. I'm going to create a new file, JWT maker test.go inside the token package. Then let's add a new function, test JWT maker, that takes the testing.t object as input. First, we have to create a new maker by calling the new JWT maker function and pass in a random secret key of 32 characters. We require no errors to be returned here. Next, we generate a username with the util.randomOwner function. And let's say the token valid duration is gonna be 1 minute. Let's also declare two variables to compare the result later. The issued at time should be time.now. And we add the duration to this issued at time to get the expired at time of the token. Okay, now we generate the token by calling maker.createToken function and pass in the username and duration. Require no errors. And require the output token to not be empty. Next, we call maker.verifyToken to make sure that the token is valid and also get back its payload data. Require no errors. And require the payload object to be not empty. Now we need to check all fields of the payload object. First, the payload.id should be not 0. Then the payload.username should equal to the input username. We use require.withinDuration to compare the payload.issued field with the expected issued at time we saved above. They should not be different by more than 1 second. Likewise, we compare the payload.expired field with the expected expired at time in the same manner. And we're done. Let's run this unit test. It passed. Cool. So that's how we test the happy case. Now let's add another test to check the expired JWT token case. Similar as before, we first have to create a new JWT maker. Then we will create an expired token by calling maker.createToken. Pass in a random username and a negative duration. We require no errors to be returned, and the token should not be empty. Now we will verify this output token. This time we expect an error to be returned, and more specifically, it should be error expired token. Finally, the output payload should be nil. Okay, let's run the test. It passed. Excellent. The last test we're gonna write is to check the invalid token case, where a non-algorithm header is used. This is a well-known attack technique that I have told you in the previous lecture. First, I'm gonna create a new payload with a random username and a duration of 1 minute. Require no errors. Then let's make a new token by calling JWT.newWithClaims with the JWT.signing method none and the created payload. Now we have to sign this token using the signString method. But we cannot just use any random secret key here because the JWT Go library has completely forbidden from using the none algorithm to sign the token. We can only use it for testing when we pass in this special constant. JWT.unsafe allows none signature type as a secret key. If you follow the implementation of this value, you can see that normally the none sign method is disallowed, unless the input key is this special constant. It basically means that you are aware of what you're doing. Make sure you only use it for testing and not for production. Okay, let's get back to our code. Require no errors. We have to create a new JWT maker as in the other test. And now we call maker.verifyToken to verify the token we've signed before. This time the function should also return an error. And the error should be equal to error invalid token. The output payload should also be nil. We should remove this column because both payload and error are not new variables. Alright, now let's run the test. It passed. Awesome. So now you know how to implement and test JWT in Go. Although I think the JWT Go package was quite well implemented in terms of preventing security mistakes, it's still a bit complicated and difficult to use than necessary, especially for the token verification part. Now I'm going to show you how to implement the same token maker interface but using PASETO instead. It will be much easier and cleaner than JWT. Okay, let's open the browser and search for PASETO Golang. Open its GitHub page and copy the URL. Then run go-get with this URL to download the package. Now get back to our project. I'm going to create a new file, pasetomaker.go, inside the token folder. Similar to what we've done with JWT, let's declare a type pasetomaker struct, which will implement the same token maker interface but use PASETO instead of JWT. We're gonna use the latest version of PASETO at the moment, which is version 2. So the PASETO maker struct will have a PASETO field of type PASETO v2. And as I just want to use a token locally for our banking API, we will use symmetric encryption to encrypt the token payload. Therefore, we need a field to store the symmetric key here. Okay, now let's add a function new PASETO maker. We take the symmetric key string as input and returns the maker interface or an error. This function will create a new PASETO maker instance. PASETO version 2 uses Cha-Cha-Poly algorithm to encrypt the payload. So here we have to check the length of a symmetric key to make sure that it has the correct size that's required by the algorithm. If the key length is not correct, then we just return a nil object and an error, saying invalid key size. It must have exactly this number of characters. Else, we just create a new PASETO maker object that contains paseto.newv2 and the input symmetric key converted to byte slice. Then we return this maker object and a nil error. Again, Here we see a red line under the maker object because it's not implementing the token maker interface yet. So let's do the same as what we've done for JWT maker. I'm going to copy these two required methods of the token maker interface and add the PASETO maker receiver in front of them. Okay, now the red line is gone. Let's implement the create token method. Similar as before, we first have to create a new payload with the input username and duration. If error is not nil, we return an empty string and the error to the caller. Otherwise, we return maker.paseto.encrypt and pass in the maker.symmetric key and the payload object. The last argument is an optional footer, which we don't need, so I put nil here. And that's it. Pretty short and simple, right? If we follow the implementation of this encrypt function, we can see here it is using Chachapoly cipher algorithm. And inside this new cipher function, it also checks the input key size to make sure that it equals to 32 bytes. Alright, now let's go back to our code and implement the verify token method. It's very simple. We just need to declare an empty payload object to store the decrypted data. Then call maker.paseto.decrypt with the input token, the symmetric key, the payload, and a nil footer. If error is not nil, we return nil payload and error invalid token. Else, we will check if the token is valid or not by calling payload.valid. If there's an error, we just return nil payload and the error itself. Otherwise, we return the payload and a nil error. And that's it. Very concise and much simpler than JWT, right? Okay, now let's write some unit tests. I'm going to create a new file, paseto-maker-test.go inside the token package. Actually, the test would be almost identical to the one we wrote for JWT. So I'm just going to copy it here. Change its name to test PASETO maker. Then here, instead of new JWT maker, we call new PASETO maker. And we don't have to change anything else because PASETO maker implements the same maker interface as the JWT maker. So let's run the test. It passed. Now let's copy the test for the expired token case. Change its name to test expired PASETO token. And update this code to new PASETO maker. Then run the test. It also passed. Excellent. We don't need the last test because the none algorithm just doesn't exist in PASETO. You can write another test to check the invalid token case if you want. I leave it as an exercise for you to practice. And that brings us to the end of this lecture. We have learned how to implement both JWT and PASETO using Go to create and verify access tokens. In the next video, I will show you how to use them in the login API, where users provide their username and password, and the server will return an access token if the provided credentials are correct. Thanks a lot for watching this video, and see you soon in the next lecture.